The question wants us to calculate the second ionization energy of the helium atom to four significant figures. So here is the sort of equation that happens when you ionize a helium atom, specifically the second ionization of it, where it spits out an electron and becomes He2+. So knowing that it's He+, we can use a very good equation to figure out the second ionization energy. So the Rydberg equation is shown down here, and it works basically for any atom that is only one electron. And He plus, normally He, the ground state He, has two electrons. However, it's now that it's He plus, has lost one electron, meaning it only has one left. So here we can use the Rydberg equation, where the R here is the Rydberg constant at 2.17 times 10 to the minus 18th joules. And another important thing that we want to note is that ionization energy is measured in kilojoules per mole, so we need to make that unit conversion at the end. So this equation on top here is the Rydberg equation that I mentioned before. So let's go through what all the variables mean. So change in energy is essentially what we are solving for. It's how we solve for the ionization energy. This is the Rydberg constant, as mentioned before. Z is the atomic number, basically the number of protons that the element has. NF is the final shell of the electron that is basically making the jump, and Ni is the initial shell of the electron. And in this case, since it's He plus, the initial shell is 1. So Ni equals 1. And then Z is 2 because helium has 2 protons. And NF, the final shell, is going to be infinity because basically the shell is infinite. The electron is just leaving the atom basically and has no contact with the nucleus anymore. So if you remember calculus, or if you've taken calculus, you know that 1 over infinity basically approaches 0. So we basically treat that as 0 using a little bit of calculus here. And that makes the equation a lot simpler. So it goes up to here, where the 1 over infinity squared becomes 0 and cancels out. And then we get a positive number again, which makes sense because you have to put in energy to ionize something. And then doing a little bit of number crunching, we get the value of 8.716 times 10 to the minus 18th joules. Specifically, the units on this number is joules per 1 atom of helium, and then we need to convert it because we want kilojoules per mole. So, to finish off this problem, we need to do a little bit of a unit conversion, which hopefully you've done before in chemistry, where we start with joules over 1 atom of helium, and we want to come out with kilojoules per moles of helium. So we multiply by 6.022 times 1023 atoms of helium over 1 mole, and then this gets us joules over mole. And then finally, we multiply by 1 kilojoule over 1,000 joules, which gets us kilojoules over moles. And then we get this answer here. And notice this is to 4 significant figures. If you go any more significant figures, then the answer is technically not correct. Thank you.